Hello, Algebra 2. Welcome to Lesson 7.6, Solving Rational Equations and Inequalities. Go ahead and pause this warm-up and press play, and I will go over the answers. I'm going to have to move through this quickly because there's a lot of slides and a 15-minute time limit. Okay, number 1 is joint variation with a constant of 1/2. Number 2 is direct variation with a constant of 7.5. Number 3, 6.4. Number 4, 15. Number 5, 325 miles. And number 6, 4.5%. So previously we've simplified rational expressions. Now we're going to solve rational equations and rational inequalities along with applications and word problems. So some new vocabulary here. Pause the screen at any point if you feel you need more time. A rational equation is an equation that contains one or more rational expressions or fractions. Weighted average is a method for finding the mean of a set of numbers in which some elements of the set carry more importance or weight than the other. And a rational inequality, we have some techniques for solving them, which we'll cover in more detail later in this presentation. Okay, example 1, solving a rational equation. If you'll notice here, we also need to check our solution. If you notice here, we have fractions. 5/24 plus 2/3 minus x equals 1/4. We want to eliminate the fractions by multiplying through by the least common denominator. What's the least common denominator of these three denominators? 24 times 3 minus x. 4 also goes into 24. You can basically just multiply each of the denominators together. So we're going to do 24 minus 3x times both sides of the equation. When you do 24 minus 3x times 5/24, you're going to get, the 24s are going to cancel. Then you do 24 minus 3x times 2/3 minus x. The 3 minus x's will cancel, and then over here on this side, the 1/4 times 24 is going to reduce to 6. So when we simplify this, we have 15 minus 5x, distributing the 5 here, plus 48, 24 times 2, equals 18 minus 6x, distributing on the other side the 6 to the 3 minus x. Then we just simplify using properties of algebra, combine like terms, add the 6x, subtract the 63, and we get x equals -45. Checking our solution, if we throw in -45 into that equation and simplify, we can see that the solution is correct. You can also use a calculator to verify it much quicker. So the solution is -45. Okay, here's one for you to try, very similar. Try to multiply by a least common denominator and simplify. Least common denominator is 2 times x minus 1, leaving us with a result of x equals -1/2. Okay, here's another rational equation. Let's take a look and think about what do you think the LCD is here? Well, there's two denominators, p plus 1 and p minus 1, so we'll use that as our least common denominator. So we're going to multiply everything times p plus 1 times p minus 1, every single term, all three of them. So here the p plus 1s cancel, here the p minus 1 cancels, here nothing cancels. When we divide the common factors, we have p minus 1 times p squared minus p minus 5 equals p squared minus 7 times p plus 1 plus p times p plus 1 times p minus 1. Now we have the fun task of multiplying it all out by distributing p to each of these terms, -1 to each of these terms. FOIL this, multiply all this out, and combine your like terms. When we simplify, we're left with a cubic equation. Let's set it equal to 0. So we'll move everything to the right. P to the third plus 3p squared minus 4p minus 12. Let's see if we can factor this. How would we factor this? By grouping. We group here, we pull out a p squared in the first group, we're left with p plus 3. We pull out a -4 in the second group, we're left with p plus 3. So this factors into p plus 3 times p squared minus 4, or p plus 3 times p plus 2 times p minus 2, meaning that p is equal to -3, -2, and +2. Let's make sure we check our solutions. I'm going to trying p equals -3, we substitute -3. I'm going to use a calculator here and show you that when we substitute -3 on both sides of the equation, as written above, we get a true statement, -7/2. So that works. If we do the same thing with p equals -2, we get -1 on both sides, so that works. And when we try p equals 2, we get -1 on both sides, so that works as well. So the solutions are -3, -2, and +2. You do need to be careful about solutions not working, particularly ones that make the denominator undefined. Okay, you go ahead and try this one. Multiply through by the least common denominator. You might also note that x minus 2 times x plus 4 is x squared plus 2x minus 8. The final solution here is x equals -2. Okay, so there's a couple of real-world problems here. I'm going to zip through these pretty quickly. I'm not sure that there are really a lot of them in your packet, but you can pause and review or use your book for support if you need to. Aaron adds an 80% brine, which is salt and water solution, to 16 ounces of solution that is 10% brine. How much of the solution should be created to create a solution that is 50% brine? So Aaron needs to know how much of a solution needs to be added to an original solution to create a new solution. Each solution has a certain percentage that is salt. That's what brine is. The percentage of brine in the final solution must equal the amount of brine divided by the total solution. So, for example, in the original, there's 10% of 16 ounces. We're adding 80% of an unknown. So that would be our new expression. Total solution, though, would be 16x and 16 plus x. Percentage of brine in the solution is going to be the amount of brine divided by the total amount in the solution. So therefore, let's go ahead and use this information to write a proportion. Percent over 100 will be equal to the amount of brine over the total solution. That's what percent is out of 100. So let's substitute. We want 50%, so 50 over 100 equals the amount of brine over the total solution. We can simplify the numerator. We can multiply through by the LCD. We could also cross multiply, but we can multiply by 100 times 16 plus x, divide out the common factors, and simplify using properties of algebra. And we end up with 21 1/3, right? So Aaron needs to add 21 1/3 ounces of 80% brine solution to make a solution that is 50% brine. You can check your answer. If we check 21 1/3, you can see here I use my calculator. I do get 0.5, which is what we were looking for. Okay, here's a problem for you to try, very similar. Go ahead and set it up the same way and see if you can come up with a solution. Correct answer is 10.4 ounces. Okay, a distance problem. Lilia swims for 5 hours in a stream that has a current of 1 mile per hour. She leaves her dock and swims upstream for 2 miles and then swims back to her dock. What is her swimming speed in still water? So understand, we're given the speed of the current, the distance she swims upstream, and the total time. Swimming upstream against the current is harder than swimming downstream with the current. She swam 2 miles upstream against the current and 2 miles back to the dock with the current. The formula that relates distance, time, and rate is d equals rt, or d over r equals t. Let r equal her speed in still water, then her speed with a current is r plus 1, and her speed against the current is r minus 1. So the time going with the current would be 2 divided by r minus 1, plus the time going against the current equals the total time. So then we can solve this equation by multiplying by the LCD of r minus 1 times r plus 1, or r squared minus 1. So that means that r minus 1 will cancel out, and the r plus 1 will cancel out in the two fractions. And when we simplify, r plus 1 times 2 plus r minus 1 times 2 equals 5 times r squared minus 1. And then we can distribute. We end up with a quadratic equation that we can see if we can factor. 0 equals 5r squared minus 4r minus 5. Well, let's just go ahead and use the quadratic formula and solve for it. Quick substitution and simplification gives me about 1.477 or negative 0.7. We can't have negative, so speed must be positive. So the answer is about 1.477 miles per hour. And we can give it a try. And we can see that when we put in 1.477, which we rounded, we get something that's very close to 5 miles per hour. Okay, here's one for you to try, multiple choice. See if you can get the correct answer. And it's D. Okay, one last real-world example work problem. Wooey and Uema mow lawns together. Wooey, working alone, could complete a particular job in 4.5 hours, and Uema could complete it alone in 3.7 hours. How long does it take to complete the job when they work together? So we're given how long it takes them to work alone to mow a particular lawn. We need to determine how long it would take them together. You have to look at their rates. Wooey can mow the lawn in 4.5 hours, so the rate of her mowing a lawn is 1 over 4.5 lawns per hour. Similarly for Uema. And then the combined rate is 1 over x. So we know that we've solved 1 over 4.5 plus 1 over 3.7 equals 1 over x. We can combine the fractions because these are just two numbers, and then cross multiply or multiply both sides by x, and we get about 2 hours, 2.03, but about 2 hours. Don't put too much attention into the word problems. Don't put too much worry into them. But, we can check it out and make sure that it works. And we can see that it's pretty close to 1/2. See if you can answer this one. And last thing we're going to talk about is solving rational inequalities. Step 1, state anything that's excluded. These are values for which the denominator is 0. Remember, we can't divide by 0. Solve the related equation. Then use the values determined from the previous step to make a sign chart, divide a number line into intervals, similar to what we did with quadratic inequalities, and then we can test them. So let's take a look at this one. First of all, what's going to cause this a problem here in making me divide by 0? Values that make the denominator equal to 0 are excluded. For this inequality, the excluded value is 0. If k is 0, we'll be dividing by 0. So let's go ahead and solve this equation. 9k would be the least common denominator, so let's multiply everything by 9k, giving us 9k divided by 3k is 3, plus 2 equals 6k, which means 5 equals 6k. K equals 5 over 6. So we're going to draw vertical lines at the excluded values and at the solution to separate it into intervals. So 0 is an excluded value and 5 over 6 is a solution, creating 3 intervals. That's where the sign changes can happen. Now, we're going to test a sample value in each region to determine if the values satisfy the inequality. So let's pick something less than 0, -1. Okay, if we do k equals -1, then, and we test it in there, do we get a true or a false statement? Is -5/9 less than 2/3? Yes, that is true. So k is less than 0. This interval is a solution. Let's test a number between 0 and 5 over 6. So we chose 1/3. If I plug in 1/3, I get 5/3. Is 5/3 bigger than 2/3? No. So that's not a solution. And then pick something bigger than 1. And if we pick something bigger than 1, then and test it out, we get 5/9. Is 5/9 less than 2/3? Yes, it is, because 2/3 is actually 6/9. Therefore, k is greater than 5/6 as a solution. So we have solutions in this interval, and we have solutions in this interval. So k is less than 0, or k is greater than 5 over 6. Okay, give this one a try. And the correct solution is x is less than 0 or x is greater than 4. That pretty much does it for Chapter 7. Good luck with completing your assignment. Please reach out to me if you have any questions.